So now we're gonna have equal signs with these. Now the good news is if you can factor, this goes pretty well. Okay, if you can't factor, don't do this section until you can do it with some efficiency. Okay, not necessarily you don't have to be a master at it. I mean, if you are, that's good too. But the reason why that is because what we're going to do is we're going to make all of the equations equal to zero. They may not start out equal to zero. The first ones will, just to get us started. But eventually they're not going to equal zero. We're going to force them to equal zero on our own. So we're going to take the numbers into our hands and we're going to take control of them to do what we want. Well, so yeah, the equation, it actually has to equal zero. So it's not just a goal, it's kind of has to be that way. But this zero factor property right here, it's saying A and B. Think about it like this. So let's look at what this means, okay? A times B, which they may not be just individual values, they could be binomials, which we've seen, right? After they've been factored. Anything times zero is zero, which is good news, because if I can make this binomial, which it'll eventually be binomial, if I can make it equal to zero, then I don't really care what happens to the B, because anything times zero is zero, including zero. If I can get this one as well, which eventually it'll be a binomial, if I can get this one to equal zero, then the whole thing ends up being equal to zero, okay? So what we do is we end up taking these two factors, which are usually binomials, and then setting them equal to zero and solving them as separate equations. That will tell us the values of x, which if you were to replace into the original equation, of course, this is after factoring, right? Usually. So if you go back to the original equation and then solve these two binomials for zero, then you can replace those numbers into the original and you get zero, and that's great. Sometimes if it's squared, then you only got to do it once, which is kind too. But sometimes A and B are, that's what I was talking about. Polynomial is talking about binomials specifically. A quadratic is a polynomial with a degree of 2. I don't know why that's important. Oh, that's why. Because if it has a degree of 2, usually that means that you're expecting 2 answers. If you see that the degree of the polynomial is 3, expect 3 answers. Expect it. It doesn't have to. Sometimes the answers actually repeat, and so you end up with only 1. It's just a maximum number, right? So if it was a degree 4, you can expect 4 and then so forth. I said too much there, but I had fun doing it. So on this one, on this one, here's my 2 factors, right? So I'm going to start with this first factor, x. Okay, so here's the thing, is if I could make that x equal to 0, I don't really have to solve this equation. I just found a value of x that would make the whole thing equal to 0, and I'll prove it. Okay, so the original equation, x times x minus 2. I won't do this checking too often in this part, not at least by hand. So I said I'm going to replace the x's with 0, right? So this x is 0 and this x is 0. And I know 0 times 2, I'm doing this the long way, but just to kind of prove a point, 0 times negative 2 is still 0. 0 times 0 is true. Okay, so that tells me right there, boom, I found one solution. And it is a solution because when I replaced the x with 0, it made it true. The other factor was this x minus 2. So if I could get that x minus 2, and I'm creating a new equation, it's separated, but it's focused on this binomial, right? If I could get that to equal 0, it would still make it true, right? And again, I'll check just pretty much on this one, but right here I'd have to, not everyone needs to do this, I know, but I am. So I'm going to drop the x, I zeroed out my minus 2, x equals 2. That should be a solution, but will it work? Well, the original equation was x times x minus 2, and it should be equal to 0, right? But now we're going to replace both x's with positive 2. Okay, so 2 times 2 is 0. This should equal 0. 2 times 0 is 0, which does equal 0. That's true. And now I know I have, in fact, found another solution. So we get 2 solutions on this, 0 and 2. And we checked them. Both of them are solutions. We checked in the original equation. Always check in the original equation. Use a calculator if you need to. So it's a fine way to check, but we good. Now, before we go to the next problem, do understand that this would have started, usually it's going to start out as something like this. It's going to say something like x squared minus 2x equals 0. Okay, so it was already factored for us, but in the future, do expect to do some factoring. Of course, this was just the greatest common factor, but they did it for us. It's a nice way to start out.